Hello, I'm George Malin, the Managing Editor of Vanilla Plus, and welcome to today's webinar, the topic of which is Best Practices for Onboarding, Verification and Continuous Monitoring of Virtual Network Functions. I'm delighted to be joined by Ihab Mana, a Solution Architect, and Kader Khan, the Director of the Simulators Business Unit, both from Expo. I'll shortly hand over to today's speakers, but first I'd like to set the scene. As communication service providers move from pilot projects and trials of network functions virtualization in isolated parts of their networks, deployments of far larger scale are beginning to happen. Large operator groups are committed to virtualizing network functions, and 2018 will be the year in which we start to see the technology really having an impact. This is borne out by some of the projections from consultancies and analyst firms across the industry. McKinsey, for example, estimates that moving to NFV and SDN would let operators lower their capital expenditures by up to 40%, thereby pushing these costs down to less than 10% of revenues. The firm also says that the network operating expenses would be reduced by a similar amount, so it's clearly compelling in terms of the savings, although savings are only part of the coin when it comes to virtualization, and there's many other things to think about. Other data also paints a enthusiastic picture. A recent World Economic Forum and Accenture report stated that widespread adoption of virtualization technologies will be driven primarily by network cost reduction. 64% of operators rated this as the main adoption trigger, and it's estimated that SDN and NFV could generate savings of 25 to 75% of overall operator operating expenditure, and that's thanks significantly to reduced provisioning, monitoring, and hardware costs. These attractive numbers make a clear business case for virtualizing network functions as soon as possible, but they don't address the sheer complexity of onboarding, verifying, and continually monitoring virtualized network functions, or VNFs. It's important to remember that this is a new landscape for operators, and one that is far removed from their traditional physical infrastructure in terms of how it operates. Add to this that the new architecture is constantly changing as the network reconfigures itself to support different demands, and what you have is a requirement to assure services in a constantly changing environment. Although the technology will be new when deployed, this is not an experimental environment. Operators will be held to tough new service level agreements by their customers, especially if operators are using the new capabilities of VNFs to charge a premium for specific levels of service or for other attributes. Equally, virtual networks will be under scrutiny internally, with managers monitoring to ensure that key performance indicators are met and the promise of the technology is being delivered in reality. Networks that can identify and rectify problems before they occur, while automatically provisioning bandwidth to where it is needed most, are likely to become essential as complexity increases exponentially. A network servicing 10 million endpoints and 10,000 nodes could see these numbers increase by up to 5 times by 2020. In terms of incidents per hour, that would lead to a 25 times increase from 400 incidents to as many as 10,000 per hour, an amount that's impossible to handle manually, obviously. So with that sheer scale and the thousands and thousands of potential incidents that are being projected, it's vital that virtual network functions onboarding, service chain activation, monitoring, and troubleshooting are optimized. And this is why I think today's webinar topic is so important for the future of the telecoms industry. Ihab and Kader will explain the challenges and describe some of the best practices involved in addressing each of these critical activities. Later on, they'll also open the floor to your questions. If you'd like me to put a question to Ihab or Kader, simply enter your question into the panel on your screen, and I will ask them it at the end of their presentations. Now, without further ado, I will hand over to Kader. Kader, the floor is yours.
Thank you, George. Thank you very much. And I do see good participants today in the call, and a lot of operators participant as well. So I'm pretty sure that those participants, service providers here today do understand that they have to transform their networks, right, to NFV and SDN to be more relevant and competitive. Well, this transformation of NFV and SDN is must for building cost-effective, faster, and smarter network to cater customer expectation and ever increasing the bandwidth usage. So from their point of view, I'm sure that they agree that they have three key objectives, and it's not going to happen overnight. This transformation is not going to happen overnight, and it's going to happen in phases addressing those three key objectives. And the first one is CapEx reduction, which normally is achieved through building a software-based network. And the second phase would be the OpEx reduction, where they would introduce automation in the form of open APIs and integrating with orchestrator and automation environment, DevOps environment, and so on. And finally, the third objective is increasing revenue, and that they can achieve by bringing new services to the market. By adopting some of the good technologies, next generation technologies such as DevOps, microservices, and so on. So these are the three objectives they would achieve in steps from phase one to the final phase. Now, the secret of this whole transformation lies on how well they are able to understand their network horizontally as well as vertically. In other words, 360-degree view. Right? This is very important for their success. From the vertical point of view, a lot of probe systems that we have been traditionally using can be used. And from horizontal point of view, active service assurance testing is key to understand the behavior of the network end-to-end and also at the demarcation points. Well, this is not new if you basically look at it. We have been doing this in many, even the physical networks. But however, what is important is how do we achieve this in the virtual network? And why? Because it's very important. We have been hearing in the market about zero-touch network and complete automation and so on. So this understanding the 360-degree is very, very important to build a zero-touch network that is capable of, as an example, self-healing, self-learning without any manual intervention. So that's going to play a key role in achieving reduction in the total cost of ownership for the service provider's point of view. Okay. So if you look at from the test and measurement and the service assurance point of view, considering what I just spoke, what we believe at Expo is that more than ever, right, in the complete life cycle of business and operation life cycle of service providers, more than ever, the testing and service assurance is going to play a critical role throughout the life cycle management. Right, that's what we believe in. What we are going to do in rest of the webinar is that I will be talking about pre-deployment experience, Expo's experience in pre-deployment testing, working with service providers, and Ihab, my colleague, in this call, he'll be talking about operation side of it. Okay. So before I get into the details about pre-deployment testing, let's start with some basic fundamentals. I'm not going to explain here the NFV architecture. Pretty much, I'm confident that most of us in this call know about NFV architecture. But what is important to understand is every block in this NFV architecture has its responsibility to do. Right? If you start from the virtual infrastructure management layer, it has a responsibility to create the virtual resources and present it to the next upper layer. And similarly, if you look at the VNF manager point of view, it has a responsibility to do the package managements, VNF package managements, and lifecycle management to deploy the different VNFs, level 2 to 3 VNFs, or let's say level 4 to 7 VNFs, and manage them. And if you go to the one layer above, the NFVO has a complete responsibility to orchestrate the resources as well as the services and the lifecycle management of the complete network service. So every block has its responsibility to do. But the question is, how are we going to tell these different blocks to do what we want them to do? Right? That's most important to understand. So the answer to that question is descriptor files. Right? So the descriptor files that you're going to define, and that's going to be a part of your VNF package as an example, right? It's very important. It's required to manage and connect everything in the network. Let's say, connecting the hardware to the virtual resources, to the VNF, and to the network services. If you take as an example onboarding process, if I have to define what is the onboarding process, it's the process of submitting these VNFs or the network service package to the catalog that you see in the left-hand side of this slide. It's called as NS catalog. So the onboarding process is all about submitting your packages so you can use this package to instantiate your VNF and network services later on. And without having those descriptor files or defining those descriptor files, the NFVO does not really know how to perform its functions. As an example, lifecycle management or fault management or performance management, it really does not know how to do that. So the descriptor files are very, very critical with respect to in the onboarding process and the lifecycle management afterwards. Now, we know once you get everything up and running, the next question is, there's going to be changes in the network, right? The NFV network is all about dynamically changing various different things when it is in operation. Like, you scale the new VNFs or you descale them or you add resources or you migrate from one place to another place. There are many things, right? There's going to be changes in the live production network. So the next question is, like I said, how are you going to keep track of these changes, right? So the answer is what you see in the right-hand side, right? The NFV instances. This is the block that is going to keep the data up to date, so you know at a given point of time the exact situation of the network's condition. Right? So this is very, very important to understand. The descriptors or in the NS catalog is very, very important on the initial configuration time, and the NFV instance block is going to keep up-to-date information about the changes and the current status of your networks and the network services. So having said that, now we know that there are many, all the blocks that we talked about in NFV architecture, there are many blocks are well defined by HC, and there are some more work to do, definitely. But from the service provider point of view, right, to move ahead into the virtualization of their network, they have various options in front of them to select. Obviously, today there are many vendors, VNF vendors, orchestrator vendors, VNF manager vendors are out there. The biggest challenge for the service provider is to select the best mix of vendors for their NFV strategy. This is the biggest challenge in front of them. And of course, in the development phase of when you're building the network in the development phase, the pre-deployment testing is staple for the service provider to learn, understand, and select the best equipment for their networks. It's key as such. It's a staple, right? Pre-deployment testing. Now, during pre-deployment testing, what do you actually do? There are 5 things that we recommend service providers to do. They should start with testing the NFV platform, followed by testing the VNF, the functions of VNF, and the VNF management functions, followed by the network service, the complete end-to-end network service functions, as well as the network service management functions. So these are all the 5 things that we recommend to test. Now I'll kind of explain every step what exactly are the objectives that you should follow in testing every steps, and how do you actually perform the test, and what kind of a KPI that you will have to measure in every step. Right? So let's start with NFVI testing. So in NFVI testing, there's 2 key objectives. Right? The first objective is how do you prepare your NFV platform to cater the performance requirement, let's say the VNF and the network service that you are going to build on top of that NFV platform. So that's going to be your first objective. If you look at NFVI particularly, right, most of us adopt OpenStack or VMware, and if you look at these technologies, this is decade-old technologies, and there are various tools that are available from the HP Open NFV platform, and to characterize the performance, along with some of the pre-deployment tools, traffic generator tools, you can actually do that. Who would do that? The infrastructure vendors who normally build the infrastructures. They are if they have an experience in building the cloud data centers, normally they know how to do this job. But the key here is that you should prepare the network in a way that the NFV platform, in a way that when you are going to deploy the VNFs and the network service, it is able to handle it. And it's important to do this at the stage 1, because if you don't do this, when you wanted to test the VNF and the network service, you might discover some basic faults that kind of might hinder your actual VNF and network service testing. So that's why this objective one is very, very important. Now let's, what's the second objective here is you as a service provider, you should focus while you are testing, right? And during your tests of VNF functions or performance and network service functions and performance, what is the impact of NFVI, right? The first objective is before you actually test the VNFs and network service, and the second objective is while you are testing it, what is the impact of the platform? So this can normally done by collecting the data from the test tool, as an example, X4 test tool, collecting the data from the system that you are testing, whether it is a function under test, however you call it, device under test, or network under test, system under test. So the data that you collect from there, and finally the data that you collect from the platform, right? So you should be able to take this platform and be able to create the KPIs that you would want to see. Right, and talking from the KPI point of view, some of the KPIs that's very common that you need to measure or displayed in the slide. As an example, processor usage, utilization for compute, packet drop count, error with respect to network, and memory buffer, and so on with respect to memory. Even in your test plan, you can craft. Some of the cases we have crafted a test plan and work with some of our customers to create a detailed KPIs. When I say detailed KPIs, it's the next level KPIs. I'll give some example. As an example, instruction per second, from the CPU point of view. And what is the automated way of recovering the disk failures? How much time does it take MTTR to recover the disk failures, right? And sometimes even for some of the operators, we have seen that the one-way and two-way latency becomes very, very important. And in some cases, what is the storage input-output and throughput and storage latency and so on. So you can even craft your test plan to measure these kind of KPIs in this step one. So objective is basically to ensure that NFVI is prepared first, and also while you are testing the VNF and network service, you are able to get how the what impact is incurred at the NFVI side, and able to correlate and collect the statistics that can kind of help you to size the system and dimension the systems and so on. So that's what you do at step one, NFVI testing. Okay, and let's move on to the next step, VNF testing. So what is the objective here? So here the objective you should have is to first to characterize the functional behavior of the VNFs, right? The VNFs that you're going to deploy in the NFV, it could be a level 2 to 3 VNFs or level 4 to 7 VNFs. Let me give an example. So level 2 to 3 VNFs, you can consider router. vRouter is level 2 to 3 VNF, and level 4 to 7 VNF or vFirewall, or even the mobile network VNFs, as you see in this picture, such as VSBC, VMME, VS Gateway, VP Gateway. These are level 4 to 7 VNFs. And your focus should be to test these VNFs and measure the KPI and also test the services that these VNFs support by wrapping around these VNFs with the pre-deployment test tools, right? Some from X4 or whichever the test tool that you're using. So while you are doing this wraparound testing of VNF, you should measure certain key KPIs. But one thing that I would like to share here is that some labs, what we have experienced is that initially they think, okay, the vendors have migrated the software that was running in the hardware to commercial off-the-shelf hardware, and it should work. The functionality of these devices should work, and it should not have a greater impact. But based on our experience testing different devices working together with our customers, what we understood is, and I would actually use this word, please be advised that that most of the variables, right, that we have to deal with in NFV, as an example, allocating dynamically the resources for the VNFs in case of scaling, descaling, scale out, scale in, scale up, and scale down, and even the resources that you allocate in vSwitch, and the type of hypervisor that you are going to use in your NFV platform, and as well as if you look at from the VNF vendor point of view, they implement a lot of technologies, cloud-native technologies, as an example, to do things better in commercial off-the-shelf hardware, multi-tenancy design. So these are some of the examples, right? So all these different examples that I just said has they have to, the vendors have to re-architect for implementing all these different things. That eventually had impact on some of the basic functionalities, and we have seen some of the basic functionalities even break. So don't skip this thinking that functional testing is not that important, because of the different variations. We have seen some basic thing works, and the same KPI that you see in this slide, the basic KPIs that even we measure it in the physical world, like availability, retainability, quality, security, and mobility KPIs, differs. Like every variations that you are going to introduce and test it, the measurement of all these different KPIs differs. And in practical world, when you are deploying the VNFs, it's going to behave dynamically, and you have to foresee all these different KPIs, how it is changing based on the different variables that you are introducing in the testing, and measure them, so you know when you are actually going to production, you're prepared for it, right? To handle different kinds of situations. Okay, so that's the first one. The first objective is you should characterize the functional behavior, and the second objective is performance verification, benchmarking, and dimensioning. So what do I mean by performance verification is, first, you have to start from the basics, right? You have to first understand, okay, given the resources to the VNF, what it can support, what is the maximum performance and capacity it can support, how many subscribers it can support, and how many calls it can take per second, and how many calls it can sustain for concurrent calls it can sustain for longer period of time. So those are some of the examples. So you have to first do that, and once you do that, then you can push the VNF and benchmark, okay, how much maximum it can support. Because remember, end of the day, NFV is all about reducing the total cost of ownership. You just don't want it to throw away a lot of hardware just because you wanted to let it work, right? So the cost efficiency and cost savings can be achieved if you optimize the whole thing. And finally, the third one is the dimensioning. So if I have to talk about dimensioning, normally based on our experiences, there's different ways service providers dimension it, right? So they basically rely on the theoretical value from the vendors. And on the papers they do the calculations and they build the network. That's one way. In some cases it has worked, but obviously in the dynamic nature of NFV, it's kind of risky, obviously. And the second one is doing some kind of test and error kind of a method, or the simplest way is over provisioning, right? But I stress upon again from our experience, NFV is all about reducing the total cost of experience. So you should use or in the pre-deployment testing phase, you should do the tests that are required to optimize as much as you can to understand and effectively use the resources you need, right? This is very, very important. And we recommend highly on this. I mean, it's not. It's a cumbersome process, but you can start with the fixed configuration, and slowly introduce different variables and do the incremental testing and try to measure the same KPIs with different types of variables. So once you have all those KPIs with different values by testing different variables, you would be able to conclude and dimension the system that is more efficient. Okay. And why is it very, very important, the VNF testing, is because, every traffic, the customer traffic that traverses through this VNF is subject to reliability, if you think about it, right? And if it is subject to quality of experience and the predictability requirements and the complete quality of service and experience of the user. So make sure that you measure all these different KPIs, from the level 4 to 7 VNF point of view. But if I have to say a little bit about level 2 to 3 VNFs, I would say you should also measure the KPIs, one-way, two-way delays, forwarding, misrouting, and most importantly, integrity tests you must have to perform. Like, for example, okay, I originated this traffic. Is it really going to the destination that I expect it to go, right? So these kind of measurements that you must do when you're testing level 2 to 3 VNFs, in addition to the KPIs that you see here for level 4 to 7 VNFs. So that's our second category, and it's very important to test this as a step 2. And the step 3 is the management functions. So So what is VNF management function? I kind of explained this. The different blocks in the architecture has different functions to do. As an example, lifecycle management and performance management, fault management, packet management, image management, right? There's a lot of things that the management functions do. And the VNF manager is responsible to conduct management related functions to the VNFs that are deployed on the network. So that's the objective of this step 3, and obviously there are many management functions that you need to test, but I'm going to focus here on lifecycle management and more particularly the elasticity, scaling in and scaling out in this particular slide. Okay, so let's start. Once you have onboarded all the VNF packages and every details is available in your catalog, you are ready to start, stop, or scale and terminate all your VNFs and build your VNFs and do different things with it, right? And build the network service and so on. But what is complex, in our testing, what we have discovered was the lifecycle management. It's really very complex of them all, right? And when you are testing the lifecycle management, there are various things that you need to consider. You basically start with, of course, first understand the stability of the VNF with the given resources and create a base, right? And once you create the base, and the next thing that you do is you create the thresholds that are required for the elasticity testing, scale up and scale down. There's different types of thresholds that you can set. You can set the thresholds based on NFVI characteristics such as memory, CPU, and I/O, and you can set the thresholds based on application-specific characteristics such as number of subscribers attached or number of subscribers registered in the IMS, and the throughput from the application point of view, number of bearer connections. So you have to set some thresholds. So you set thresholds and different levels of thresholds. As an example, you start with setting a threshold and you say, okay, I set this threshold. That means when that threshold comes, I should start looking at initiating the scalability procedures, right? Or at least be aware that I need to initiate the scalability procedures. And then you set another threshold where you exactly start the scalability procedures and so on. So you need to set the threshold. And once you set the threshold, then what you need to consider here is to test different types of scalability testing, right? So you can scale the VNFs in different ways. So you can scale the VNF triggered by the NFV orchestrator, and I think it's basically called as auto scaling. And you can also scale triggered by the VNFs by knowing, okay, what's happening with the VNFs, or something goes wrong functionally or whatever reason, right? So you can scale triggered by the VNF via VNF manager. It's basically called as on-demand scaling, and you can also scale manually from the NOC or nowadays SOC operations or operators from OSS and BSS. So you can do different types of scaling. Different types of scaling can happen in your network. So while you are doing the scaling testing, one of the observation maybe it's worth sharing here is most of the time what we found was the load balancing function, right? When you're scaling, you're going to have multiple VNFs and there should be a load balancing function that's going to distribute the traffic to multiple VNFs. So the load balancing functionality, many times we have found it as a bottleneck. That's something to focus on. The other thing is the metrics that you need to measure in the scaling has to be very accurate. So it's preferably the physical test tool can become handy in this case. When I talk about measuring the KPI, I mean by, let me give an example, right? So I talked about different thresholds. So from the KPI point of view, it's really very difficult to measure. As an example, you should be able to precisely measure some of the metrics like when the trigger is introduced, right? The time the trigger is introduced, and when it is detected, and when the scaling procedure has to be started, right? That's another metrics that you need to measure. And when the scaling procedure is started, when the new VNF is created, and is it ready to start taking in the traffic, right? So what's the time for that? And after it becomes ready, when the first time it's when it is taking the traffic in, how is it performing, and how is it performing in the subsequent traffic that is taking in, right? So these are all some of the metrics that you need to measure. These are very complex to measure, and that's why I kind of mentioned here the physical test tool more than a virtual test tool can come very handy. So these are the different types of variations that you need to consider, and when you are measuring with different types of scaling methodologies, the same KPIs, you will see different numbers, and that numbers will help you to do different dimensioning, scaling, and understanding how you need to learn and understanding how you need to architect and do the system. Right? And the next, that's the third one, the most important thing. And the next one is, the fourth one is the network service testing. It's more or less, variables that I talked about in the VNF testing is applicable here, but not just for the VNF, but it is end-to-end, right? Because the network service is all about connecting all the different VNFs and creating the network service and testing them horizontally, the functionality of that network service, such as voice over LTE or voice over Wi-Fi. The service is actually working and it is providing the right throughput, KPIs such as throughput, quality of service, and quality of experience, and so on. And how do you achieve this? So in case of VNF testing, you connect the pre-deployment test tools such as simulators around the VNFs. But in this case, what you do is you connect the simulators end-to-end, and you generate functional tests or load tests of millions and millions of subscribers and media, line rate media, to characterize the performance of the service end-to-end. Like I said, again, you have to ensure that you start with simple, and then you introduce different variables, such as when you're using the hypervisor used, resources used, and different things. Introduce different variables and measure and collect the KPI, because it's going to help a lot. And the definite thing is the results differ when you introduce different variables. So that's from the network testing point of view. And the final one is the network service management testing point of view. This is a very interesting thing. If you recall my discussion about explaining the descriptor files and instances, all these different things will come handy while you are testing this, to go and look at what was the initial configuration and what is the current configuration afterwards, and so on. Okay, so if from a little bit of definition from the architecture point of view, NFV orchestrator, it's responsible. It's the brain, right? It's responsible for managing the life cycle of one or more services, working together with some of the other blocks that we looked at, like VNF Manager, NFVI, Vim, and even OSS and BSS, and so on. And here, the lifecycle testing, let me focus again here, the lifecycle management of the network service is very, very important, and it's complex as well. I'll give you some example. Why do I say it is very complex? So when you're defining the network service, you can define all the VNFs that are available in the same servers or multiple servers, right? Or in some cases, those VNFs are defined in one data center, in the network service, and some other VNFs in the network service can be defined in another data center. And it's quite common. So if you want to place some of the VNFs closer to the users, that takes care of the media, voice, video, and things like that, it's common to keep those media VNFs closer to the user. So there is going to be a network service, and you would expect, and you will have that the different VNFs in the network service will be in same server, different servers, as well as in different data centers. Now, when you are going to do this kind of complex network service, you need to measure different KPIs to understand what is the impact when it is running in the same server, different servers, and different data centers. So that's what I mean by saying, the testing of network service in the pre-deployment testing is complex and very, very important. And if I again go back and focus just to connect to whatever I trained or talked about in VNF slide in the network service management, testing elasticity of the network service, like VNF elasticity testing is very, very important as well. And again, here there are multiple variations in addition to what I discussed in the VNF. Some of the variations are, it's possible that you might just create a new VNF instance, which is normally called as a consecutive VNF instance, to increase to increase the capacity of the network service to handle increasing number of subscribers using that particular service. And the second option is, what you can do is you can scale the VNFs in a way that multiple smaller blocks inside the VNF, it's called as VNFC, or instantiated to handle the increasing subscriber usage for that particular service. That's the second way of creating the meeting to the demand. And the third one is you can simply just increase the hardware resources to one VNF. So these are the various ways that you can increase and decrease the capacity of the network service while you're dealing with the increasing number of subscribers starting to use your service. So when you do all these different types of variations, again the KPI differs. Right? So it's important to consider those things in your test plan and make sure that you measure them, and which will really be very helpful for you. And talking a little bit from the KPI point of view, some of the KPIs from the network service is key. Like for example, in the network service, the first thing what you do is you will instantiate the VNFs. So how much time does it take to instantiate the VNFs? Then what you do is you connect different sub-blocks in the VNFs, which I call it as VNFC. You connect that together. Then you create multiple VNFs that makes up the whole network service. And then you have to prepare that network, like connecting the ports, subnets, IP addresses, and so on. So how much time does it take to do that? And then once you have the complete connection, and how much time does it take to complete the whole NS instantiation time? And after that, it's the same like VNF. What is the latency when it is starting to take the first call and subsequent calls? What is the throughput that it can start taking without any fail and can hold it for a longer period of time and so on? So these are some of the KPIs that you should focus on while you're testing them. Okay. All right. So that kind of concludes the 5 key areas from the pre-deployment testing point of view. What you need to do in the development phase of the service provider lifecycle management. The other one important thing is total cost of ownership. Like I said, what we believe is that the future data center is going to have a mix of different types of hardware, GPUs, DSPs, CPUs, and if every single these hardwares have and can do special things, right? As an example, GPU can do concurrent and simple logic, CPU can do complex logics, and so on. When you are choosing the VNF vendor, I have implemented the cloud native and I've used these hardwares and the software acceleration technologies. It's important to craft the test plan to test these. I'll tell as an example, right? If some of the complex logics are implemented in GPU instead of CPU, or repetitive tasks that FPGA is good at doing is implemented in CPU, the total cost of ownership is going to considerably increase. Okay, so you have to create your test plan in such a way that you consider all these different things and you make sure the vendor implementation is going to help you to reduce the total cost of ownership, which is very, very important. So the test plan should consider that as well. And finally, talking about the test configuration, it's pretty straightforward. When you want to test the wraparound testing, you use the pre-deployment tools around the VNFs, and when you use the end-to-end testing, you use end-to-end. And obviously, you need to have a test manager which is capable of helping the automation environment to create and run the test automatically. Here, I would like to share commonly asked questions. Most of them normally has. Should I use the test VNF or physical test tool or a virtual test tool? Well, the answer is very simple. If you are looking at measuring the predictable performance, use physical test tool, or this is very important, use the virtual test tool that uses cloud native hardware acceleration hardware acceleration technologies such as FPGA, that is capable of measuring the nanosecond accuracy, right? So either use physical test tool or choose a virtual test tool that uses the hardware acceleration technology, because what is important here is the measuring in a nanosecond is very, very important here. So that's the answer to that question. And the second common question that we keep asking is should I use the test tool inside or outside, right? Pre-deployment test tool. Well, it doesn't really matter. You can use anywhere, but make sure that you don't compete with the same resources that you are allocating it for the real the network services and VNF. Because if you're going to use it, it's going to create a noisy neighbor effect, and all the KPIs are going to be not looking good, right? The next one is the pre-deployment testing. Is pre-deployment testing enough? right? So we know it is staple, you have to do it, but we also have to consider that NFV has got a lot of variables, and there's a lot of variables that you're going to find in the production system. And if you have to build a robust system, only way is, obviously, you need to finish your pre-deployment testing and also continue testing it in the live production network, unlike in the physical tool, right? You have to do load testing. You have to do, synthetic traffic generation using the service assurance tools, 24/7 monitor it, and you have to do this continuously to build your network and then the services in a robust way. It's very, very key. You have to do pre-deployment testing and also continue to do that in the production testing. And the last question is, one of the things is talking about DevOps, development and operations. We keep hearing this question, how do we improve the efficiency? So the most important thing is the test repeatability and reusability. So you should be able to create the tests and everything in the development side of it, and you should be able to reuse them in the production side of it. And there should be a seamless transition from the pre-deployment to the production testing. So that's very, very important, right? So having said that, I will hand over now the floor to Ehab, who will cover the operation side of it. Ehab?
Thank you, Kader. And good morning and good afternoon to everyone. Thanks for attending. I will cover the second part of the DevOps operation, which basically, after you do the onboarding and you design your service and you validate it and test it, you have it now available for the customer to, or for whoever wants to instantiate this service and start to actually use it. And there is a fundamental difference between the way we were doing things in the past and the way it will be done in the future, or it's already been done in any cloud-native architecture, is the fact that this is not a waterfall design and waterfall service design where you design the service and you validate it to the maximum extent as building blocks, and then you deploy these building blocks in a physical network and you use it. This is a software environment, which means you have the flexibility to develop things in an agile way where you develop it, validate it, run it, but then you can also continuously do modification and changes to the service design and add new feature and add new capabilities and scale it up or move it around, add new policies of operation. It's a continuous process of developing and maturing the service. And service assurance or test and monitoring is an integral part of this process, is how you make sure that your services are working properly, and any change you do to it, it actually improves the quality of the service, not actually degrade the quality of the service. So even some of the aspects that Kader spoke about or explained can actually, there is a possibility that it could also happen while the service is running, if the service provider choose to use these kind of validation. Like, for example, when you do scaling or you move services around or you change some parameter in the service, it is possible that you can do some simulation test or do stress test before you actually enable the service to the end user. So this is, I wanted to stress on that this is not a waterfall. It's basically an agile way of developing services. I'm gonna touch on, okay, now the service is there and it's deployed. What's gonna happen after that? What are the tools and the visibility, test and measurement tools that are available that can help us to make sure that we're delivering a service that first it's available, it's resilient, and meets the customer expectation. I want to stress or bring up a point that is fundamental, and that point is In fact, historically, that's how when we start building the network, back the physical network, even before IP and during the deployment of IP, is that we have the belief that the network equipment can provide everything we need to monitor and assure the network. And that's kind of a myth, because network equipment can provide you what each equipment can see or can has a visibility to, and it's usually limited to what the network equipment can monitor from traffic point of view, from the point of view of the equipment itself. But that's a very network-centric view, and it's not a user in customer network view. So you could have all the equipment providing data that it's saying that, the network works fine, but the user actually have a bad experience. It could be also the other way around. Sometimes the user have a good experience because there is buffering, especially with most of the application today are video and multimedia that have already built-in buffering techniques. So you could be consuming your buffer while the network have issues, and the network tell you that there was a congestion. But that congestion was not at the time frame where the customer was watching his buffer video. So this is just an example of why the network-centric view will never tell you the will never tell you the user experience. So you really need visibility that looks end to end, and it's real time, which means that it requires some kind of active intelligence, an intelligent that intelligent monitoring that actively find out what actually the users are experiencing, and provide that as a way to make sure that the services are provided at the expectation of the customer. The other issue is usually customer experience rely on the time of the day or the usage of the network, and that can be only done at the analytics level, where you can collect all this information, correlate it to the events, the overall events that the customer is experiencing. So from that point of view, that will explain the next points that I'm going to explain, which is what are the things that can happen during the service in operation that requires monitoring and active monitoring. First is after you onboard the service and instantiate it, you will want to activate the service end to end and do activation tests. In the existing network today, we call that birth certificate, which means this is the time where the customer is able to start to use the service. And the activation test basically look at all the aspects of the customer expectation. One is connectivity. What is the quality of experience with the customer in terms of connectivity? And then after that is all the reachability to services and servers that involved in the service. Like, for example, if there is DNS server, firewall, any video servers, IMS, all the components that's been part or designed into the service, part of the service chain, that they are actually reachable and they meet a certain baseline of functional performance. That will tell the customer that whatever you signed up to is already met. If the next step is to go through validation every time the customer choose to scale up or scale down their services. One of the major advantage of SDN network is the fact that give the customer to have an elastic service where they can increase and decrease the service according to their demand. And that, in a way, improve the utilization of the network, the overall utilization of the network for all customers. So, for example, if you have a call center that has a certain peak time, you can study that peak time, and then you can start designing your service. As a customer, you can customize it so that you can increase the SLAs during this time and then decrease it in the time where there is low demand. And that probably will make it available for another set of customers that's sharing the network at the same time. So that improved the network utilization and the usage of the cloud. So in this case, every time the customer they change their service, then they can validate that. Finally, is a continuous monitoring of that service so that you can see that you can realize if there is the SLA are not met before the customer actually complain, which will reduce the penalties. If we look at that in detail quickly, we can see that when the customer do the activation, then a T1 test, for example, will be issued, and then the result will be returned to the orchestrator, and the orchestrator at that time will look at the result, whether it's success or failure. If it's a success, then it will go on with the service. If it's a failure, then it will have a remedy of what to do in terms of troubleshooting. And the next step, as I explained, is the customer will have a portal, and the portal will enable them to do some level of customization and change to the service, that every time they do that change, they can come back and do the activation test and test for whatever the changes they made to the network, that they are valid and they are the service is still meeting the SLAs that with the new expectation. And finally, the continuous monitoring. So that will be an opportunity actually for service providers to sell additional assurance services where they can provide continuous monitoring to the services that the customer asks for, and even other services as well that is not even part of that service. Meaning if the customer is buying only connectivity, but they do have their own components in their own cloud, in their own private cloud, there is a possibility for the service provider who provides connectivity to actually provide additional service to assure and monitor these other services as well. So this is an opportunity for service providers to actually generate revenue from assurance and help also the customer to analyze their network and continuously optimize the usage of this network for revenue and quality at the same time. I just want to point out that actually we have a very large suite of tests that does this intelligent active testing, which covers from layer 2 to layer 7. And that's really enabled the customers to have a large possibility of monitoring the network, not just connectivity, but also other aspects that are very important to the customer service, like reachability to services and responsiveness and resiliency of the components part of the service. So with that, I wanted to give an example of how service assurance and active testing, just one area. There is passive monitoring, there's simulation, there is fiber monitoring. We have a very large portfolio of components that can be integrated as microservices with orchestration to be part of this operational phase of the service. And I just wanted to give one simple example for activation, validation, and continuous monitoring, just to give you a flavor on what can happen during the operation to validate the service. Finally, I will summarize. The industry is moving to automation and DevOps, and that's really what we call the holy grail, where service provider finally will start to increase revenue, because reduction in CapEx and OpEx, as Kader explained, is definitely a great objective, but it's the revenue that will really help the service providers to survive this inflection point in the market. Then the testing deployment provide foundation for the success of the service. If there is no pre-deployment testing, then the customer experience may decide the fate of the service that is not a good service, and that's definitely not a good thing. Then finally, the service offering, active service assurance, help in providing the customer an experience that is even beyond what the experience today in terms of 5.9. It's auto-scaling and self-healing may actually help providing a 100% available service to customer, even if it's built on top of a cloud that based on open source and component that may not have this 5.9 capability. So it's really a major leap in this industry, is to actually help in reducing the cost and increasing the user experience, the quality of user experience. And with that, I can conclude the presentation part and pass it to George.
Yes, thank you very much, Ihab. It's interesting that I said at the start that this is a area characterized by complexity, and it certainly helped to listen to these very comprehensive presentations to understand them. We can turn quickly to take only a couple of questions, I'm afraid, because of time. The first question we've had in, I'd like to put to Kader. The question is, considering many NFV interfaces are still under development, how is it possible to understand the impact of an NFV platform while testing VNFs? Kader, what's your view on that question?
That's a good question. So, like I explained in my slide, different vendors have different APIs, because the APIs have not yet been standardized, and there are some APIs that are standardized and released, like VNFM and so on. But right now, what we see is more of a proprietary API. So the way that we solve this problem is we work very closely, hand in hand with our customers, and we understand what kind of a KPI they're looking for, and we understand what kind of how can we get the data, and we understand how to correlate the data along with the pre-deployment testing data that we have to present the KPI that they need. So that's the way that we are engaging with our customers today, but it should change once the interfaces are being fully defined and the vendor equipments have those implemented. It should become more standard way of creating the KPIs and presenting them to the customers.
Okay, excellent. Thank you, Kader. The next question that I have is how far along are most of the operators that you work with in this process? And I guess that varies a lot, Kader. Or Ihab, what are your views on where operators are in this process right now?
Yeah, you are right. This is Ihab. You're right, George. They are in different stages, and Basically some are in the phase 1, some are in the phase 2, some in phase 3, and some of them are in all phases at the same time. So it's really not a linear process. Everybody's learning and everybody is trying to do their best, basically.
Okay, excellent. I think we've got time to squeeze one more in, actually, although it is the top of the hour. The question we've had is the massive buzz of SON self-optimizing networks a couple of years before 4G launch was massive and very promising, and promised some of the same terminology used nowadays for virtualization, such as self-healing and self-configuration and others. What are the differences now that can give more confidence to the early adopters, especially because you've just explained a lot of manual activities rather than actual automations? So I guess the question is, what's different now from SON at the dawn of 4G? Carter, can you answer that?
Yeah, I'll start answering. Ihab, you can add if you have comments from your end. So one of the questions that I understand hearing is that what's the difference between SON and automation that we are talking about now? So SON is more focused on the radio side of the network, but what we are talking here is about the complete network end-to-end, not only from the service point of view, but also both the horizontal, vertical integration with OSS. So it's a big thing compared to SON, but obviously SON can work together with NFV to make more efficient automation and orchestration. That's the answer for the first question in that. And the second one was, there's a lot of manual work rather than the actual automation. We talked about 3 phases. We talked about virtualization, the first phase where you can reduce the capex, and the second phase is automation, and operators are in different phases. Different operators are in different phases, and so on. So, definitely it is a very complex system, considering it's the whole end-to-end network, not just focusing on the radio network. It's definitely complex. That's why we used many times. It's complex and complicated. But however, from the automation point of view, it's going to happen in phases. You can use the open APIs, or you can use the DevOps, Ansible, CDCI tools to work closely with the resource orchestrator and service orchestrator, which is the components of NFVO, to build a complete automation together with SON to create a bridge between the radio and the complete network, and make the future much agile and faster to operate and cost effective and so on. That's my take on this answer. Ihab, do you have anything to say?
No, that's well said. Thank you.
Okay, excellent. I'm afraid we're at the point where we've pretty much run out of time. So I'd like to thank our panelists today, Ihab Marna and Carter Khan from Expo, for sharing their expertise. It's certainly a fundamental part of the telecoms industry's future success, and a very complicated subject to learn. So thanks very much for sparing the time today to talk us through the best practices. I'm George Maynham, the managing editor of Vanilla Plus. Thank you very much for joining us. And if you want to go over any of the content from today's webinar, it will be available online within the next 24 hours, so you can re-listen to some of the more complex sections if you wish. Thanks again for joining us, and thanks also to our participants. Goodbye.